Hello and welcome to G Fun Facts Online. Let's talk about dust. You know, that stuff that collects on your bookshelf or creates little bunnies under your bed? It seems pretty boring, right? Just tiny, lifeless specks of dirt and skin. But what if I told you that high above our heads, some of these dust particles are on an epic journey, transforming into microscopic chemical factories that are cooking up a recipe for air pollution? For a long time, scientists thought that dust particles, especially the larger ones whipped up from deserts like the Sahara, were too big and dry to be chemically interesting. They were just passive travelers in the atmospheric winds. But incredible new research has completely flipped that idea on its head. It turns out it's not the fresh dust we need to worry about, but what happens to it as it travels for thousands of kilometers. This process is called atmospheric aging. Imagine a single grain of dust starting its journey in the Gobi Desert. As it floats through the air, it acts like a tiny magnet, collecting coatings of other chemicals. A key one is calcium nitrate, which forms when the dust reacts with nitric acid in the atmosphere, a common pollutant. This new jacket is a game changer because it makes the dust particle hygroscopic, which is a fancy way of saying it gets thirsty. It can start absorbing water vapor right out of the air, even when the humidity is as low as 8%. This is where things get really wild. With this thin film of water, our dust particle is no longer just a speck of dirt. It has become what scientists are calling a chemical reactor in the sky. A tiny airborne crucible. Within this microscopic layer of liquid, a whole host of chemical reactions start to fire off. One of the most significant things these flying factories produce is something called secondary organic aerosols, or SOA for short. These errant pollutants that are pumped directly out of a tailpipe or a smokestack. Instead, they are secondarily formed when various gases, from natural sources like plants and man-made sources like traffic, react with each other in the atmosphere. And we now know that aged dust particles are a major hotspot for creating them. How major? Studies have found that during dust events, more than half of all water-soluble organic carbon, which is mostly SOA, is found in these large, aged dust particles. This was a shock to the scientific community, which had long assumed SOA formation was mostly happening in much smaller particles. Professor Zhongbo Shi from the University of Birmingham puts it perfectly. These aged dust particles act like a sponge in a reactor, absorbing gaseous pollutants and transforming them into particles that affect our health and the climate. Global models now suggest that these dust-driven reactions could be responsible for up to 2/3 of all SOA in the world's dustiest regions, from North Africa all the way to East Asia. That is a massive amount of pollution we were previously misattributing. So why should you care about these tiny airborne chemical reactions? Because they have huge consequences for all of us. First, our health. The SOA and other pollutants created on these dust particles contribute to what we know as PM2.5 fine particulate matter that is small enough to penetrate deep into our lungs and even enter our bloodstream. This is directly linked to millions of premature deaths worldwide and can cause or worsen everything from asthma and bronchitis to heart attacks and strokes. Second, our climate. Aerosols like dust and SOA play a huge role in the Earth's energy balance. By changing their chemical makeup, these aged dust particles also change their size and how they interact with sunlight and water. They can become seeds for cloud droplets or ice crystals, directly influencing cloud formation, rainfall patterns, and how much of the sun's heat is reflected back into space. Getting the science right is absolutely critical for making our climate models more accurate. Of course, this whole process is incredibly complex. The type of reactions that happen depends on the original minerals in the dust, the specific pollutants it flies through over cities and industrial zones, and atmospheric conditions like sunlight and humidity. And this isn't just an outdoor problem. Some of these pollutants settle indoors, where house dust, a mix of skin cells, fibers, and outdoor particles, can continue to act as a reservoir for these harmful chemicals. So the next time you see a hazy sky during a dusty day, remember what's happening up there. It's not just dust. It's a vast, airborne chemical experiment where countless tiny reactors are turning natural dust and man-made pollution into a more potent threat. This new understanding shows us that to tackle air pollution effectively, we can't just look at smokestacks and tailpipes. We have to understand the intricate dance between the natural and man-made worlds, a dance that's happening on the surface of a single, aged grain of dust. Thanks for tuning in to G Fun Facts Online. Join us next time for another deep dive into the amazing science that shapes our world.